In this video, we're going to do a Mercator problem. I'm going to start by drawing the navigational triangle. Then I'm going to show you how you can use Bowditch to see what formulas you need for your particular example, and then I'm going to solve it. Okay, so first thing up, we have a vessel at this latitude and longitude heading for a destination at this latitude and that longitude. So that's the point of departure, this is the point of arrival. And the question is, what's the course? And really what they're talking about is the course from north, the course to steer, and the distance. Okay? So what I'm going to do now is I'm going to draw the triangle. And this is going to help me out to figure out various calculations that I'm going to need to do. So 37 north, 178 west. All right? So what I'm going to do is I'm going to start off with a little dot here. And that essentially represents where I'm leaving from. That's my point of departure. So that dot right there is going to be 37 north, and that would be the latitude, and the longitude would be 178.15 west. Okay. Great. Now, I'm headed for a destination that is 34 north. Okay, so I'm 37 north, 34 north. That means I'm going to go south. Okay, so I'm going to go south first. Well, I'm not. I'm actually going to go like that. But anyway, I have a southerly direction, and then the question is, do I have an easterly or a westerly direction? All right. So, looking at this right now, 178 west, 178 east. That's a little confusing to me. So I'm going to draw just another diagram. Okay. This is going to be the diagram looking down, like sort of at the North Pole, where this is 0 degrees longitude and this is 180. And I'm starting at 178 west, so I'm going to go like this. That's longitude 1. And I'm going to 178 east. That is this longitude there. That's longitude 2. And according to this diagram, if my direction of travel was to the clockwise, then that means that I am traveling west. Okay? So that means that my navigational triangle would look like this. Okay? That's my triangle. So that means that this is C, this is L, this is D, and this is going to be a P and D low. Now, this is also going to be M. We're going to express this southerly direction in terms of L, and we're going to express it in terms of M. Okay. But another way that we could think about this is that we're going to go to this latitude, and we're going to end up going to this longitude. So this was 34.18 north, and this was 178.25 east. Okay, so when I go to calculate little l, I'm going to get the difference between these two. So essentially, what I'm going to do is I'm going to subtract those two. So that's how I'm going to get little l. And when I want to get the d low, I'm going to figure out the difference between them, okay? And since I'm crossing the date line, I'm going to add those two and then subtract them from 360. So this diagram also helped me to figure out how to do the math to calculate little l, okay, and also d low. And we're going to do that in just a minute. Okay, so course and distance. So, oh, by the way, one other thing. I want to use this diagram to help me figure out the relationship between C and CN. So there's sort of like a little kind of formula you can use. It's CN, the course from north, is equal to north-south, C, east-west, okay? And this is your quadrantal notation here. So since I went to the south, my prefix will be south, and since I'm going to the west, my suffix will be west. So C, the relationship between C and CN is going to be CN is going to equal south, C, west, okay? Great, and we'll need that later on when we do that. Okay, so now, that being said, let's go to Bowditch and figure out which example we are. So I'm trying to find course and distance. So I go here, and here is my first example. It's on page 585 of Bowditch. Okay, and this is Bowditch 2, 1981. This is the one that's used in the exam room for U.S. Coast Guard licenses for deck. So here is example 1. Oh, find course and distance. Oh, this is it. Great. So looks to me like these are the three formulas. These are the two formulas I need. I'm going to do tan C first, and then I'm going to solve for D second. So I'm going to go. Let me just write those over here. Tan C, okay. Tan C equals D low over M. and D equals L, secant C, okay? So I'm going to rewrite both of those formulas, and we'll take it from there. So if we look at these formulas in a little bit more detail here, my first formula I'm going to solve for C, okay? My second formula I'm going to solve for D. So I want to look at the inputs for C, for this first formula. Well, in order to solve for C, I need D low and I need little m, D low and m, okay? Well, my diagram here already showed me how to calculate D low. I'm going to add these two and then subtract from 360. So that's how I'm going to calculate D low. That's good. The question is, how am I going to calculate little m, all right? Well, little m is going to be meridional parts that are going to be proportional to the two latitudes. So I have my two latitudes. I'm going to have to look up my meridional parts in Table 5 of Bowditch 1981. Okay? And then once I have that, I can take D low and divide it by m. And then, I'll do the inverse tangent on that. We'll see that in just a minute. Now, the other one, D, L secant C, I'm going to transform that into something that doesn't have secant in it, but I need little l and c, okay? So I'm going to get C by doing this formula. Little l, I'm going to get by doing that subtraction. Okay? So what I want to do, though, is I just want to take a quick peek at Bowditch to see how Bowditch set it up. Okay? Oh, we have to calculate D low. There's Bowditch calculating D low. And then we have to calculate M. Well, there's Bowditch calculating M, but in order to get M, there's M, we needed L1 and L2 because we're going to look up M1 and M2 from those L's, okay? So anyway, what I'm trying to show you here, though, is that Bowditch, in Bowditch's example, we're going to use it as a model. So what I'm going to do is I'm going to set my problem up just like this. I'm going to get my difference in latitude, I'm going to get my little M value and my longitude. I'm going to do that right across here. So let's see here. Longitude 1 was greater than longitude 2, so I'm going to put that one at the top to make the subtraction easier. So, latitude. So I'm going to go like this. L1, L2, little l. And then I'm going to go M1, M2, little m, okay? And I'm just basically setting things up the same way Bowditch did. So the next thing I'm going to do is longitude 1, longitude 2, D low, okay? Now, looking at my diagram, I'm going to figure out if I'm supposed to add or subtract. So this looks like to me I'm supposed to subtract. And if I subtract here, I subtract there. And then over here, since I'm crossing, it doesn't matter if I add or subtract. I'm going to add them, and then I'll subtract from 360. Okay? Great. So now I can start to populate a little bit. L1 is 3724 north. And L2 is 3418 north. Okay? So so that direction of L is to the south, so that becomes south. And then when I do my math, I get 306. Okay, great. Now let's put our longitudes in. Longitude 1, was 178.15. That was west. And longitude 2 is 178.25 east. And we said that direction, okay, was to the west. So now I'm going to add those two. And when I add those two, I should get 356.40. Okay? And now what I want to do with that is that 356.40 is this. So I'm going to subtract it from 360 to get that. So D low is going to equal... but 360, I'm going to make it 359.60. I just took one from there, threw it over there to make the math easy. 356.40, and that becomes 20 and 3. So that was 3 degrees, 20 minutes to the west. Great. All right. Now, let's just take a quick look back at Bowditch for a second. So these are not our numbers, but this is our example. We calculated little l, and it's in degrees, minutes, and we calculated D low, and that's in degrees, minutes. Let's just look at what Bowditch did. Oh, Bowditch did that. Oh, but then Bowditch converted it to minutes, and Bowditch converted D low to all minutes. So good enough for Bowditch, good enough for me. I'm going to do that too. So to do that, what I'm going to do is I'm going to take 3 degrees, I'm going to multiply that by 60. That's going to give me 180, and this 6 drops down. So little l is 186 minutes. Okay? And I'm going to do the same thing over here. 3 degrees times 60, all right? That's going to give me 180 minutes, and I had 20 already, so that's plus 20. So D low is going to equal 200, okay? 200 minutes, all right? Great. So I've got that number and I got that number, and they're in the form ready to go into some formulas. Okay, great. But what about this M stuff? All right, so M is the meridional parts. It's proportional to L. So since L1 was on the top, M1 needs to be on the top, okay? And L2 is on the bottom, M2 needs to be on the bottom. So now I'm going to go look those up. So I have to go to table 5. If you're using 1981, you go to table 5. And I'm going to look for latitude 27, minute 24 to find that M. So I come over here, and here is, it's on page 118 of Bowditch. Okay, and if you look across the top, there are my latitudes, and if you look, and by the way, that's down at the bottom as well. Okay, so I got my the numbers at the bottom and the numbers at the top row are the same, and the numbers of the right column and the left column are the same. Okay, so these are your whole degrees of latitude, and these are your minutes. So I'm going to choose whichever is the easiest for me. I want 3724. So I go 37. This is going to be my column. And then I come down here to 24. That's my minutes. And I slide over. And right here, that is my meridional part for latitude 1. Now, just don't forget to do something. It's inferred that, this 24 is the first two numbers for all these. So it's not just 08.8. It's 2408.8. So that's the number I'm going to write here, 2408.8, okay? Great. Now, latitude 2 was 3418. So I'm going to find 34. There it is. And 18, I'm going to work on the other side over here. 3418 looks to me like that is something here. It's not 80.3, it's 2180.3. So that's 2180.3. So now I'm going to do the subtraction there, and that should give me 228.5. 228.5. Great. All right. I've got my little L, I've got my M, and I've got my D low. I am ready to rock and roll. So first thing I'm going to do is I'm going to solve this formula. Well, I'm going to solve it for C. So I'm going to go C equals tan, the minus 1 of D low over M. So now I'm going to substitute in some numbers. So D low. All right, now I got to make sure that my D low and M are the same units, and you can see minutes, and this is minutes as well, but it's not minutes of distance or arc, it's the strange minutes. Let's not worry about that. So this is going to be 200 over 228.5, and that's going to give me a C when I go with my calculator. All right. All right, so I'm going to go second tangent 200 divided by 228.5, and that gives me a C of 41.2. Okay, great. So now I'm going to do my conversion of, because they want to know the course of C to CN. So if I look here, this is C. And I want CN. So if I look at my diagram, well, I got to add 180 to 41.2. Okay, so I want that whole angle. It's going to be 180 plus 41.2. But that's also what this says. It says 180. That says plus, and that's 41.2. So anyway you slice it, I got to add 180 to this, and CN is going to equal, what was that? 221.2. That is the first problem. That is the first, that's half the problem answered right there. Okay, great. So what's the next formula I'm going to do? I'm going to do this one next. Now, I don't like that secant, so I'm going to convert this to D equals L over cosine C, okay? So here we go. That was formula 1. Now we're going to do formula 2. D equals L over cosine C. All right, well, D equals, so I want this to be, okay, so this is where I'm going to use, I took the effort to put this into minutes, and that makes sense because I want this to be in minutes at the end, distance in miles. So I'm going to go 186 over cosine. Now the question is, what am I going to stick in for C? Am I going to stick in CN, 221, or am I going to stick in C, 41.2? You should stick in C, so I'm going to go 41.2, okay? If you accidentally stick in 221.2, you'll get a negative, you'll end up with a negative distance, and you can just ignore the negative, but that will cause a problem for you on great circles, so it's best to put in C. So D is going to equal 186 divided by the cosine of 41.2, and that gives me 247.2, and that is the miles, okay? So that is the miles from this point to that point. So if I steer 221 degrees and I go 247.2 miles, I shall arrive at the second at my point of arrival. Now, just going back to Bowditch for a second, all right? You know, Bowditch, you can see Bowditch doing all that as well, okay? So here's your formula, your first formula, the second formula. Bowditch is going to calculate D low. There's Bowditch calculating D low, puts it into minutes. Here's Bowditch calculating M. Here's Bowditch calculating little l. Once Bowditch has those, Bowditch gathers them. So Bowditch took the 553, just stacked it here. Took the M, stacked it there. And then you see this C pop up. The C popped up because Bowditch then stuck D low and M into there and out popped C. But that's in quadrantal notation. Okay, so Bowditch later on converts it using the quadrantal notation to Cn. Okay, so there's the answer to that. Then the next thing that pops up is little l. Well, like, where the heck did little l come from? Well, Bowditch calculated little l and then gathered it right there. And then, well, where's this d from? Well, Bowditch is then doing this formula. So Bowditch stuck in little l and stuck in c, okay, and out popped the overall distance, and that's how Bowditch did it. And you can just go ahead and ignore this log stuff, okay? So a couple different ways of doing that. You can do your own sort of analysis of what you're supposed to, you know, solve for, or you can also use Bowditch to help you figure out what you're supposed to solve for. But I really urge you to make a nice navigational triangle to help you solve these problems.